All right. So well, that's out of the way now. Structural. All right. General molecular structural. All right. There, we're gonna come across some important information later on, but let's have a look at the question here. All right. So the question says from the compounds A to D above, select one compound which is saturated and one which is unsaturated. So if you didn't know and you draw it out like this, which one will be saturated and which one will be unsaturated? Well,
Sir, A would be
yeah.
unsaturated and the other one would be saturated, which is C.
Oh, okay. So yeah, according to the question, and that's the Chanel, right? So good to hear your
Yes,
voice
sir.
after the coach out there, but all right, it's good. So then so A, seeing that this is unsaturated, when we draw it out, again, hope everybody's seeing it. We draw out this is compound A and this is compound C. When we draw out A, it's gonna look like this, and then there's a double bond there. We automatically going to know there's a double bond because what we're seeing here, for every carbon atom, there are twice the number of hydrogen atoms. So any compound looking like that will be unsaturated. All right, because if it has a double bond in there, it means it can hold more hydrogen. So therefore, it is unsaturated, means it's not filled. All right, now, so we're saying A would be unsaturated. So we would write A as the first answer then, or they say saturated and one is unsaturated. So A is unsaturated. All right, so let me just get this eraser going. All right, unsaturated. And then of course C is saturated. Again, C is saturated because when it is drawn or when it is expanded, it has all single bonds, and so there's no space for anything to go on this compound unless you do substitution, which we'll talk about that later on. But certainly A and C will be the answers here, guys. All right. So any questions here, guys?
No, sir.
All right. All right. So A part 2 say name and give the general formula for, and look at that. They asking about general formula for the homologous series to which each of the two compounds selected above belongs. So two. Let them say name one and they give it that their name and give the general formula for the homologous series. They're trying to be smart here, man. All right. So A, we already go through this already. A, you say A is unsaturated. So if A is unsaturated, this one, I'll just give that. That will give us an alkene. The general formula for alkene we say was what again?
CnH2n.
All right, very good. Everybody remember that. This is the homologous series, guys. For those who didn't know, alkene is the homologous series that they ask for the name and give the general formula. So general formula for the alkene, as was stated, was so we'll say CnH2n. And of course, this is our general formula. So you see how the question here is going to basics. It look complicated, but it's really simple. It's some of those things. One of those things. You ever see something in a store in an exciting packaging, and when you open it, you're disappointed? It's not what
Yes,
it looks
sir.
like. Like some of them things they buy from China. Maybe some here wanna buy where it look pretty on the packaging, and then when you open it, you realize you just couple strand and put in it. You know, your $10,000 gone to waste. You know, that type of thing. So yeah, same thing. All right, so alkene as a general formula CnH2n. That's what they're asking you for here in this question. 4 marks, so you get 2 marks for this. And then, of course, C is saturated, which we said before. And that's an alkane. That's the name of the homologous series. Remember, guys, for CXC chemistry, we're looking at possibly 6 homologous series that you should know. Alkanes and alkenes are the simplest ones, usually the first ones you learn. But then there are others that you should know. All right. And here we have alcohols here. This is an alcohol. Anything ending with OH, it's the easy to pick up the alcohol. That would be the next one to learn. And then, of course, any one at CXC with 2 oxygen atoms in there would be this would be the acid. So we call them the carboxylic acid, or we can simply call them the alkanoic acid if you want to maintain the ALK naming. So this is the alcohol, as in the rubbing alcohol you use to sanitize. And that's the alcohol series. And then, of course, this is our alkanoic acid. Alkanoic acid. And I think if we go back through the topics that they will be asking, or they said that they will set the questions from, the hint is there as to the type of question they will ask you. The questions just flowing naturally here. I'm going to have a look at it after we finish this. But the alkane has the general formula CnH2n plus 2. And that's it. Do you guys have any questions here?
No, sir.
No, sir.
All right. So with organic chemistry now, and in terms of knowing the compounds, there is a progression. There is, alkanes we'll learn about first. As a matter of fact, let's start from the very basic. Because we would have learned about the crude oil. All right. There's a process known as there are 2 processes that we learned about crude oil. I don't know if anybody remember 2 processes that we can do to crude oil. But let's put it in simpler stages then. After crude oil, they may expect you to know, say, all right, you do something called fractional distillation, but nobody remember that. All right. This is what you do to crude oil to get it into the alkene. And alkene, the fractional distillation goes on there, and you get your alkene. And of course, you get your alkene. Let me see, you probably get some alkenes as well, but we can split this into 2 here. All right, so the alkane now can be this part here. This word I taught you can go through cracking, and you get the alkene. We could also by the cracking though, we could also get a smaller alkane as well. But then just I want you to understand the processes as what them can ask in the exam. The keywords here is what I want you to focus on. When you crack an alkane, a large chain alkane, you'll get an alkene plus a smaller alkane. But then because we have alkane here already, you're not going to write that. What I'm trying to do here is to show you the reactions that they could ask you about in the exam. So when you have an alkene, you can do so many things with it. So for example, you could add water. This is actually called hydration. If they ask you what they use here, you're using sulfuric acid to do that. And of course you need 170 degrees about that to do that. So you need a little heat as well. So when you have your alkene and you hydrate it with the acid, the sulfuric acid is an acid that really holds water, so good also used as something like a catalyst really. But you get an alcohol there. And then you can also react the alcohol further, oxidize it, and it turns into an acid. It turns into an alkanoic acid. So this is called the oxidation. And of course, we have our alkanoic acid. So this is the story of the organic compounds. Alkanoic acid. All right. There's a thing that happens here. We'll combine the two of them. All right. This now, the process by which you combine them is esterification. That's the name of the reaction. Esterification. This is where we make a ester. And an ester is a base. It's like it's another compound that that's responsible for fragrances. Esterification. All you see happening here is biology at work, really, because organisms like plants can make esters, but in order for plants to make esters, of course, you know that they need CO2, they need water, and they need sunlight. So when it makes glucose, it also makes other stuff. And part of the plant's metabolism is to actually make esters, which is responsible for sweet smells like bananas and pineapples and so on. So those things can be made artificially. And if we're making them artificially, this is how you'd make it. You'll get the alcohol and the alkanoic acid, and you mix them together in the process of esterification, which needs some heat. You know, you need about 180 degrees you need for that. And believe you're going to need some sulfuric acid there. But when you add these two together, with that temperature, you're going to get your ester. And that's pretty much the story. So them all right. So them want you know how much you say again? We say about 6 of them. All right, let's see. Alkane, alkene, alcohol, alkanoic acid, and ester. Have we left out any? Well, no. I think these 5 would be good for you. So you expected to know, like, well, the general formula for them, which I gave you that, but let me just highlight some of that for the others, just in case you're wondering what's happening here. This is CnH2n.
Sir,
Yes.
what kind of reaction or bonding would happen if you mixed baking soda, water, and vinegar together?
All right. That's a acid-base reaction. All right. That's an acid-base reaction. Hey, Kim, ready?
Yes, sir. Sir, explain that.
It's an acid because vinegar is an acid, and the sodium carbonate, baking soda is actually a base. So it's an acid-base reaction. So you're just going to get salt and water. Oh, and you're going to get carbon dioxide too. That's what causes fizzing. So
Okay, sir.
yeah. But CnH2n. Oh. So we're having some unstable internet here. Yeah. All right. Let's go. CnH2n, guys. Alcohols, no. If they ask you for the general formula for alcohols, it will be CnH2n plus 1 OH. Alcohols end with OH. Alkanoic acids now end with COOH. And of course, the general formula would be CnH2n plus 1 COOH. So these in there, what we have, let me just highlight that. That's the general formula for each of these. All right. So, hydration means add water. Yeah, you hydrate the alkene, you get alcohol. You can also dehydrate the alcohol and you get the alkene. So there's a little sort of reversible relationship that alkene and alcohols go through. You can hydrate the alkene, get the alcohol, and you can dehydrate the alcohol and get the alkene. All right. So a lot of stuff happen in this area here. All right. The alcohol no, with the oxidation here to get the vinegar. That's why when you have a cane factory, for example, the cane factory can easily go into the alcohol business, like Appleton can have the cane farm, and then the same farm now they can make rum because sugars are responsible for making rum. And then now you oxidize. So when the rum spoil, especially early in the manufacturing process, the rum really it can spoil naturally, and it actually becomes an acid. That's how vinegar is made. So it's made from oxidized alcohol, really. So so vinegar is a byproduct. It's rum that has been oxidized. So that's how it works. So that's it though. But if I get the alcohol and the acid separately, if I get rum, which is ethanol, and I get vinegar, which is the alkanoic acid, then we can make an ester. And usually ester is oily, very slippery. So when it is made in the right way, it's oily and slippery and smells sweet. All right, so that's the story here. CXC expected to be able to explain stuff in this area. Of course, we're not complete. This is the first part. And if you look at those topics that CXC is in, if I can find it, there you go. Okay, so that's some different subject here, but here's the chemistry, and believe I would have sent this in the group before, but and there you go. We you see this quadrant here. This is the era we're spending time on now. Sources of hydrocarbon. We talk about the crude oil already. Organic chemistry and introduction. This is where we are, and the reaction of carbon compound. That's where we are. So we're hitting this thing very hard because that chart that I showed you a while ago here, they could ask you these reactions. These are where they would ask you a lot of questions. All right. So all we need to do here is go through the past paper them and attack them one by one. All right. So, and that's what we're doing. So completing this part of the question from an 08 paper. Not seeing the rest of it, so it looks as if this paper had some fault here. But we have more. Certainly have quite a few to look at. All right. So this all right, so there's a question here. Yeah. In fact, I want to bring this one up shortly. It's a lovely one. All right, and export this to PDF here. You should see it.
Sir,
Yeah, go ahead.
sir, you say class time extended, don't it?
Yeah.
Then, sir, but the math class keep at the same time while class are going on.
Yeah, so if you have to go to the math class, you go. Well, we have to, I think all the classes there. Remember, say maths have more class than the rest of them, you know. Maths have Saturday class and marathon and all them something there. So if you feel like you need to go to maths class, you go there. But there's always the option to stay a little longer for the chemistry. So but everybody seen this question?
Yes, sir.
All right, I'm sure. All right, let me just
Yes, sir.
all right. A nice way to check your knowledge though is use multiple choice. Let's you check it false. If you can do multiple choice well and get the accuracy there, then it will come out in the paper too. Let me see what happened here. I think something is missing from this now. All right. Oh, okay. I think nothing is missing. Let me just expand it and see if we. All right. This question here, guys. Which of the compounds are shown, or which of the compounds shown are in the same homologous series? All right. So it's resembling a past question that they asked before. But which of those compounds are in the same homologous series? This is testing your knowledge of the homologous series. So all of these are all the questions them asked about homologous series. And it's testing knowledge there. All right. Now we have C3. All right. So again, as I said, there's the trick for the alcohols. As I said before, you look out for the OH. All right. The OH is the key there. The only organic compound with OH at the end there is alcohol. All right. So look out for that. And if you follow it, remember that alcohols only have one oxygen in there. So going through these compounds, we see that, all right, this one end with OH, this one end with OH. But you see that?
Yes, sir.
Yeah. But then
Yes,
look at
sir.
this. But this one, number 3 here, has OH, but then it's OOH. So this here is a different thing. All right. Remember that alcohols only have one oxygen. But this compound in 3 has 2 oxygen atoms, which makes it a different group from 1 and 2. Any questions there?
No, sir.
All right. So these two, again, look like the same group them come from. Never mind what happens before it, because what happens before the OH is different in both of them, but it ends with the same thing. So, as we say, you can have persons with the same, last name, but different first name. And what determines if they are family is usually the last name, the same family or the same father, especially. But so 3 would be out, and the question say which ones are. So let's see this one. This number 4 says what? C3, CH2, CH2, OH. Again, any OH, only one oxygen there. This is in the same family as 1, 2, and 4. So you should see that answer there, right?
Yes.
And so clearly that answer would be B, 1, 2, and 4. This is, so we could go ahead and write this. This is actually an alcohol. Easy, just looking at it. See OH there at the end, it's an alcohol. OH at the end there, alcohol. All right. All right. So, and then the other one now. The other one now. This is an acid. It's actually an alkanoic acid. Again, ending with COOH there. So that's the key there. So, and then of course, ending with OH, there is alcohol. So 1, 2, and 4. All right. As I say, no. Anybody have any questions about this or don't understand anything? All right.
No, sir.
All right. Homologous series. All right. Let me just reiterate the definition for it. It's compounds having the same functional group. Our same group, same active group in the compound. So OH, for example, is a functional group. Compounds having the same functional group. And in this case, example, you have the OH and also COOH. And in the case of the alkene, we have that double bond. So the functional group for the alkene would be C double bond C. So this is the alcohol functional group. This is the acid, or the alkanoic acid really. And of course, this is the alkene. These are the main functional groups. Well, for the alkenes, it will be C single bond C. It will be the alkene. But that's it in terms of the word functional group. That's a key word that CXC will throw at you. So it's good to know what it means. All right. So now you could look at 2 and give me an answer for this one. Which compound is not an alkane? Okay. So
I'm sorry, did A?
I'm saying A. All right. So which compound is an alkane? All right. A person saying A. Yeah. All right. No. What you seeing here now? This thing right out. Is it all of these now, guys? The question is, all right, it's not drawn out, so it's not a structural formula. Although instead they could have, this is not the molecular formula that you would use to like if they ask you to write this in a molecular formula, it would look like this. That's one way you can look at it. How many C's you see in here? 1, 2, 3, 4 C's, right? So the formula for that would be C4, and let's add up the H's. 3 plus 2 is 5. 3 plus 2 is 5, so that's what, 10. Now, that's it. This is it, the same thing, you know. You notice that it look different, but it's really C4H10. This is what we call the condensed structural formula. So instead of drawing out and putting the branches, them actually just, you know, do it a shortened way without the sticks them or without the branches, you know. So instead of doing this, you know, they would just write it's exactly the same. It's you know, this actually means CH3. All right, so it's the same thing. So
Sir, so the answer.
yeah, go ahead.
Sir, the answer no A then.
Well, it couldn't be A, and that's how I wanted to
Sir,
process
D then.
the answer. D. All right. Let's confirm this now.
Sir.
All right. Yes, go ahead. I see the message, Benito.
Yes, sir.
All right. So, all right. So you're saying it's D is the answer. Let's stick a pin on D. B. Let's see. It's not an alkene. All right. CH3 2 there. That would be CH3. So let's put this in perspective now. 1 C there, but it's 2 outside the bracket, so it's actually 2 C's, and then you have 1, 2 there. All right, so them trying to play they're playing games with you, man. Mess up on head. All right. H3, but then 2 times 3 is 6. And 3 and 1, 4. Oh, good. C4H then. This is actually C4H then. So B is C4H then. Yeah, let me play with the head, man. All right. I just know. It is the same thing. How much C there? So 4. 1, 2, 3, 4 there. So and then 3 H here. So and 1. That's a 4 and 1, 5 and 3, 8. So C4H8. All right. So this is C4H8.
Sir, that's the answer. So after I said D, I start working out and I realized that.
We have to stay focused in the exam, students. All right, as you know, this is C, 3 C's and 1 that are 4, so that's a C4. All right. This is what? 3 times 3, that's 9 and 1, 10. Yeah, who can do maths? All right. So you see now, them having a head now. Answer is right there in front of you, but you have to search for it. Any questions here, students?
No, sir.
All right. So that's not boy thing, you know. You have to go respect CXC, you know. So the correct answer is actually C. Because when we expand out all of them, because the trick here is to get it in the molecular formula. All right, it's written in the condensed structural formula. So it's a structural formula that is condensed without the branches. And then here is our molecular formula. So this is why it's important to know all the possible formulas in organic chemistry. All right, general first, then molecular, then structural. You also have condensed structural, and then final one would be empirical. But then these are what we're looking for. All right, so if you guys understand this well, or if you're having concern, you can watch back the video still, and it will probably shed some light going over it again. All right, guys, so that takes care of the second question. Can you do the third one? So certainly this would be this would be an alkene. And the general formula would be CnH2n. So just for sorry, my bad. Writing crap here. CnH2n is the answer here.
Sir, 3 would be B.
All right, so Casey is going with D here.
No, B.
B,
But.
okay. On the butt, okay. All right.
I'm
Sir,
going
Mr.
with
Connie.
B.
Leandro is second in it. There, Chanel.
Yes, sir.
You're in the mix there. All right, let's see. Which compound does not belong to the same homologous series as the 3 other compounds, or other 3 compounds rather? A bit of semantics there, but all right, let's go. OH, you know that these are all alcohols, so then definitely this is a no-brainer. And certainly this is good. This is B would be the answer. Any questions here?
No, sir.
All right. All right, so you see, you're getting the gist here. Just know the homologous series. This activity does, we're lacking of homologous series here. Why you have to be familiar with the structure, how each of them look, and see them even come back with this one here, number 4. Which homologous series is not represented in the compounds shown below? All right, so you have 4 of them here, so one of them is not represented here. Which one is it? All right, that's the question. You have enough knowledge to pick up this. We have, well, let's look at let's look at this one here. Let's call this one 1, and let's call this 2, this be 3, and this will be 4. All right, so what homologous series would compound 1 belong to?
Alkane.
Okay, Kimberly, very good. Shining there, definitely an alkane. What gives that away though? Why is it alkane?
Start only has single bonds.
Yeah, single bonds, yeah. Single bonds with carbon and hydrogen only. So yeah, all right. So alkane is represented here. We won't put the tick for the well, them said not represented there. So anyone who put X beside that would be it. So definitely alkanes are represented here. So we have 3 more to check. All right. What about the second one?
That's the alcohol.
Whoa, why you just come out with alcohol like that? What gives it away?
Sir, because it has the OH group on it.
OH group here. So then definitely that's the alcohol. All right. So hope everybody is seeing what's happening in here. All right. So this definitely
Yes,
is an
sir.
alcohol. Yeah. Good. All right. So that leaves us with C and D. One of them is not represented, certainly. And so let's see what's happening here. All right, what can we say about 3?
That's a carboxylic acid.
Oh, and what gave you that hint, that clue?
Sir,
The oxygen, sir.
COOH.
Oh, the oxygen. All right, so somebody said oxygen, and you're saying COOH is there. All right, sounds good. So, oh, it's not using the compressor here. That's why I was wondering how this looks. So, all right, definitely COOH is here. Pick up the functional group here. This is the alcohol. So, or rather not the alcohol, sorry, the acid, carboxylic acid. I don't know why. Maybe I have one track, man. All right. Alcoholic acid, or another name for alcoholic acid, by the way, is the carboxylic acid. And as you say, guys, the alcohol group in organic chemistry is the COOH is what define it. So this is definitely true. This is the carboxylic acid there, which if you look at 4, and by elimination it would leave the alkenes. You would have to go further, but just for knowledge sake, what 4 would be? Which one of the homologous series would 4 belong to?
Sir.
All right, Casey, you're saying alkanes?
Yes.
All right. Don't believe in yourself. That's actually correct. It's this is actually an isomer. This is a word that you should know now. I'm introducing you to the word isomer. It's an isomer of well, it's an isomer of the one that has 4. So it's an isomer. It has 4, but it's still an alkene. But that word here, isomer, and I'm gonna give you a note here. Note: isomers are organic compounds having the same molecular formula but different structural formula. No, this, if you check it out, this is C4H10. This has 4 C's and 10 H's. So, but then it is arranged differently from the butane, what you would know. The butane that you drew in your own case, it was a long chain, which looks different from what we're seeing here. Let's see if we can bring up what you drew, and it's here. Your butane would look like this. So everything drawn out here in a straight line. So that's butane. So that's true. But then what we also have is butane that can be drawn this way, where one of the C's is actually branching downwards from another C, which still, it's still 4 carbons, but the structure is different. So isomers are organic compounds again, right, having the same molecular formula, all right, but different structure. But different structural formula. All right. Any questions about this?
No, sir.
All right. So in some books, what this would actually be called, it's isobutane. To signify that it's an isomer of butane. So actually isobutane. It's butane, but an isomer of it. Which means it's variant. Now in real life, let me tell you this. It's like, it's like caffeine and what's the other thing name? Theobromine. So it's like cocoa or chocolate versus coffee. All right. They are actually isomers of each other. It's just at one turn, one compound. In chemistry, we have something called optical isomerism, where we have the same chemical formula, but the way in which it's structured in your body, it's different. It's like when it goes into your body, instead of turning the left way, turn the right way, and that makes it a different compound. All right. So that's the beauty of organic chemistry, where you have isomers, right? Isomers, they look like your body can pick it up, but then the way in which it aligns itself with your body now, by the time it's supposed to react, it's different. So, and it's almost like your body remember sugar, but then not all sugar is your body going to be able to break down. Your body can break down like glucose and then sucrose, but then there are some sugars that that if you eat it, it don't taste sweet, because it's an isomer of the sugar that you're used to. So that's how isomers are in real life, right? Look alike, but different, you know. Look the same outside, but different on the inside. All right. Any questions here?
No, sir.
All right. Same thing with twins. Some identical twins look exactly alike on the outside for the most part, but then you can tell them different. One might be bright and the other one might be fool. So whichever way you want to look at it, are there's different personalities altogether. All right. So speaking of which, anybody know those triplets at NCU?
On the Foster
What
trip.
was that sing? What's up?
What's that? NCU have 3 famous triplets there, no?
Sir, they sing. I think so.
Yeah, them sing.
Yeah, I know them.
3 little girls, sir.
Sir, the
Yeah.
girls, the brown girls.
I don't
And the
know.
Foster
I
girls,
don't need
them
to call them brown or kind of color, but I know that there are 3 there are 3 girls who born the same time.
I think it's what Casey said, foster girls.
The Foster triplets.
Yeah, faster triplets. Yeah. All right. I said, yeah, definitely. You see, don't them look alike? I mean, they look. Can you tell them differently? I guess maybe one of them.
Sir, they look exactly the same.
Yeah, that may I say. But I think there's a height difference though.
Sir, one of them have cross eyes.
Oh, you know them, Kimberly?
Yes, sir.
Okay, lovely. One of them have cross eye?
Yes, sir.
Okay. So that's why you know that one different then.
Yes, sir.
You talk to them?
No, sir, but they came to my church.
Oh, okay. Lovely. Oh, they sing at your church?
Yes, sir.
Okay, lovely. You like how them sing?
Yes, sir.
Okay, cool. Well, why not? But then them sing the same voice or them sing different voice? One of them soprano more than the other? Because I never heard them sing.
Sir, each of them has their own little difference when it comes down to them.
So like Amanda.
Oh, cool. Typical example of isomers. They just look the same, but certainly different vocals coming out of each of them. I'd like to hear them sing though. It's lovely. But anyway, on a different note, we're having these things to compare. 4 compounds shown, and which are remember the same. So you see how many homologous series question them asked over the years. You see, by going through all of these, pick any topic, and there are questions for it. I mean, not just topics, subtopics. So if it's homologous series, if you want to forget it, you just work all of them. If it's alkanes is a problem, then we can get all of the alkane questions them, and then you work through them. If it's alkenes is a problem, the same thing for alkenes. You know, this past paper bank that I'm trying to build here, it just suited for you guys. Any problem you have, we can get the practice right. But structure of 4 compounds are shown here, and they're asking which are membered of the same homologous series. Right now, you should be able to pick up the pattern here. WX, YZ, which are members of the same homologous series?
See, sir?
See?
Sir, I agree. It's the only one that doesn't have a double bond.
Oh. Okay. So all right. Let's go and see. Because so then they're saying that all of these belong to the same group then. All right. So this is certainly alkenes, alkane rather. All of these are alkenes. Alkene. And then alkene. All right, you should pick them up easy then. So, and then of course this is the alkene. So again, in terms of sameness now, you'd have W, Y, and Z. C is the answer. All right. So that takes care of that, guys. All right. So all right, so you guys seem to would have gotten the hang of this. What I could probably do is send the rest in the group and work through those.
Yes, sir.
Right.
Okay, sir.
No, what's funny here? Yeah?
So how the person say collection could wait till you say that, sir.
I couldn't wait.
Couldn't wait.
Wait, sir.
All right. There what? Before you guys go, there's this one that I wanted to look at, and I'll also send it in the group. This one is all of the this is the alkene question. The past questions are important. And this word you need to also know the meaning of. So 2 words that you should learn tonight, especially in the last part of what we're doing: the isomerism or isomers, and polymers. So isomers and polymers. All right. All right. The behavior is called isomerism, but the molecules themselves are called isomers. All right. Polymerization is the term generally, but polymers refer to specific compounds. So these are things that you will have to research. Now, this, based on the topics that CXC said, it's, they made us ask one question about polymers. It's actually, them say reactions of carbon compounds. So we don't know which reaction. So we still have to go know it. But, just be on the safe side, we have to know these. So what I'm going to do, all right, I'll try and send these in the group in a short while. All right, guys. Any questions, guys? Not learn anything tonight?
Yes, sir.
Yes, sir.
All right. Make sure you know. All right.
Yes, sir. We learn the truth. Me learn.
All right. And you need to keep this momentum going. So I would say it's time to practice. All right. And so I'm gonna roll out the questions based on the topics them, as we say. So that's the plan. All right. Then nearer to exam, then we can start look at the whole papers them and put things together. But right now the focus is in getting each topic out of the way. So as you can see, we're targeting 6, 7, and 8 for now. This will go on for this week, maybe into next week, but we know say one question going to come from 6, 7, and 8. Most likely they will be combined together. If they decide to separate them, like for example, they could they could make one question entirely about the reactions of carbon compounds and combine 6 and 7 together in one question. If they do it that way, it means organic chemistry. Those who lack organic chemistry will have the advantage here. But as I tell you, my predictions already that it's it's very likely that, as you say, they would marry these two, and marry these two. Mole concept, acid base and salt would be married there as well. So looking at 1, 2 possibility, 3 electrolysis would be something by itself. So, and then of course this certainly would be question 6, which means 4 and 5 in 4 and 5 looking like 2 organic chemistry questions. All right. And as well as we won't know the exact ordering of the questions, but we know we know the topics of the questions. That's for sure. And certainly that these 3 questions, these 3 topics, they're not likely to be mixed with all of these topics here. So that's the idea here. And they say XE do a little scrambling thing, which I wouldn't put it past them, but certainly whichever way them put it, still you guys should be ready. All right, so that's it, guys. So we're working towards this goal here. And as we say, when the time comes, wish you guys all the best. All right, so those who stayed and those who couldn't stay, thanks for being here just the same. We have, let me see, we have 8 persons online still. Some people get kick off, some people have class to go. But Bible say what? Who endure to the end shall be saved, no so?
Definitely.
Yeah, so it's try to be the one that endure. All right, so I have a lot of fixing up to do to send these papers to you guys.
Sir,
Yes, go ahead.
sir, did you get a chance to look for my lab book?
Your lab book. I didn't see a lab book. You send your lab book up at iPass?
Yes, sir.
So it's a book you're writing?
Yes, sir.
I haven't seen, no.
You never get the chance, right?
No, I haven't been up there. So maybe I need to ask.
Okay, sir, good.
Why? You made mistakes?
Sir, me just remember say me never write the reflection them. And I don't me do all like conclusion them.
You did this, you know. That is like, if reflection and conclusion is like 4 marks, you know.
Sir, may I go back for it tomorrow?
Yeah, you need to do that.
Okay, sir. And just put the other 2 in there because I just 6 did in there.
No man, if you have more than that.
Okay, sir.
Yeah, so that's all. All right. All right, guys. So any more questions? All right.
Sir,
Yes, Leandra.
we still have 2 more labs to do.
I'd stated that you have 2 labs to do. Which was the last lab you did?
Titration.
Titration one.
How much plan and design do you have?
2.
2.
If I have 2 plan and design, I need 1 more. Did I give you? I never give you one with which plan design I give? We give one with separating technique, and given you one. Which other one we given you? Vitamin C.
Yes, sir.
Okay, this one we may give still would be organic chemistry still, so no can use it and can do it and read up same time. All right, I have one about making an alcohol. I forgot to run that, you know. Let me find that right now as we speak. We have organic. We have alcohol one. All right, alcohol. Yeah, I find that one. So you know, alcohol one for real. I don't know. I mean, say are the physics people them done for them then. So just one more on a need. That tomorrow, Tuesday. All right, let me find it. All right, I get something here. All right. So I'm gonna listen on this. Meanwhile, where's the I'll send this in the group. So something we need to go through then. I'll send you some information. All right, and the lab. Now, let's see something in the group.
Yes, sir.
All right, so let's check it out. We have a fermentation lab here. Oh, beautiful. All right, I've found it. All right, I think I find it. All right. Oh, I don't know this one. No need to edit this. All right, can just send it as is, and let me just save it as PDF. And chemistry. All right, in a few seconds, it should be in the group. And definitely, I'm gonna have to go through this, I don't know, still. All right, let me just quickly highlight some things still here. All right. For this lab, all right, let's make it load over here. So, all right, for this lab, this is one way. This lab is basically like one way you can actually use to make alcohols. All right, this can be done at home. You know, you can do it in a lab. All right, so whatever the skill is going to be P&D anyway. And of course, let's put today's date again. As it's going to be 18 of the 5, 2020. All right. So what this will be about now? Talking about red stripe. Basically telling you how red stripe is made. Red stripe is actually made from cassava. All right. So, and you know, Jamaican cassava unique. So therefore, if we use the starch the right way, we get a unique beer. Right. All right. First produced in 1928 from recipe developed by Paul Geddes and Bill Martindale. You're a chemistry student assigned to research the research and product development team of Denno and Guinness Limited, and you are given a project to help them brainstorm a recipe for a new alcoholic beverage. And so you're going to use the knowledge of organic chemistry to plan and design an experiment to carry out this project. All right, guys, this I'll just give an example of the hypothesis here. You can use any starch. Think of any starch. You can use anything like sweet or have sugary or starchy properties that you can use. Yam can use. I just put that there as an example. But any fruit you want to use can use as well. All right. Just pick one and run with it. Thing is, all right. You can also look at this thing where how to do fermentation at home. As fermentation is where you convert sugars into alcohol. So that could work with anything sweet, all right, as well. So how to convert sugars into alcohol. Then when you follow the when you actually send it to you as a visual, so you can look at it. That would be your method. So how to convert sugars into alcohols. All right, and some interesting things will come up for this one. As a simple formula for fermentation. As I say, something you can do at home, guys. Something exciting. This is a simple secret, guys. All right, you get your sugar, you need yeast, and you get alcohol and carbon dioxide. Any questions here, guys?
No, sir.
All right. No. At home. All right. So has anybody made them own liquor at home? No?
No, sir.
Oh Lord. You guys missing out in the kitchen. But just let's follow the steps them. All right, let me show you this. Sugar, yeast. So in terms of method, sugar from example, you can use strawberry, anything you can get, and preferably something cheap where you don't have to go really break the bank or spend a whole heap of money upon still. You can use yam, you can even use potato can use too. Like every liquor where you can think about them use something different. Like Heineken use something different from Red Stripe. Anybody know what Heineken use? All right. Guinness use something different too. So Guinness and Heineken are examples. I think the Guinness make from some hops. Think of some wheat based thing. We grow in the European area. All right. So that's Guinness. Heineken use something different. Red Stripe use something different. So you pick your thing and do something different. Maybe this could turn you into a millionaire or billionaire. Who knows? But just pick one and run with it. All right. Research is easy. You just need something to measure out the sugar. You need the yeast. You need a container to put the yeast and the sugar in. Yeah, of course, you're going to need water. So, all right, so, oh, okay. Let me see something. Somebody joining the class at this time. How to, let me give you a more detailed thing. I usually have a fine on it. No. All right. All right. All right, here we go. Here's another example. Let me go to another page and show you this. This one now, guys. This probably you can follow. But you seeing this?
Yes, sir.
Different liquors here, but we have whiskey and we have vodka and we have wine. Notice the process is different and the steps are given here. Get potatoes, you crush them, add water to it, you boil it. Of course, you're going to put it in a container, make sure that the temperature at least fall to a certain level where the yeast can well, of course, when it's in the fermented container, you're going to add the yeast to it. All right, so the yeast, they need a certain temperature, like 45, between 30. You want to keep it at body temperature, they're about, between 37 and 43 3 thereabout. So after you boil it, and so you have to make it cool to a level, and then you put the yeast in there. Leave it there for a couple of days, and then and that's you. You're going to distill it. You know, you basically boil off the impurities and so on, but the alcohol will be a distillate in this container over here, and then that's how vodka is made. So you're getting the recipe for vodka here. This is done in Poland, as them say. And of course, so the same thing. So you're inspired here, guys. You can run with any one of these. You can use these, or let's just use something. And write your steps. That's where you get your marks from. All right, I would say any question with this, you can ask it in the group. As a matter of fact, let me save this and send it right away. You know. All right. And so in a few seconds it should be in the group. All right. Here it is. All right, so this is the one discussed. I probably might just pull back the other one. Oh, it's all right. Well, everybody read it already, so okay, I'll pull back. All right, so yeah, this is the one that's discussed, the second one. So the second one has the information there, guys. All right, so as we say, if you have any questions, guys, just you know, shout me, and then I'll try my best to answer you. All right.
Sir,
yeah.
is this a 4 PND?
The 4, the 3.
Oh, 3.
Yeah, 3 for chemistry. So
Okay.
this will be the third one for chemistry. So yeah, I'm not sure what lab number that will carry to, but certainly the 3 PNDs. So they're looking out for 3 PNDs and 3 PNDs, and the other labs them minimum of 8, but 3 PNDs have to be in the 8. All right, so this is why I get in this one. So I want to finish up, so make sure so we're on the right side. All right, so any more questions?
I don't think so, sir.
Okay. All right, guys, so that's it. So I'll see you guys. Oh well, and there's something else I probably need to talk to you about. And there's implementation as well. Now, when I love them say you have to at least try carry it out and get some results for. So it's separating technique, and the other one, vitamin C. Therefore get one gets well. I forgot to talk about this in the group because we online now. So, but let's talk about this in the group still. After I finish it, we can talk about the next step. All right. But once again, guys, thanks for being here, and look forward to seeing you on Wednesday. I would say any questions before that, just use the group and stay in touch.
Okay, bye, sir.
All right.
Thanks, sir.
Yeah,
Okay,
bye.
sir.
All right.